So, good afternoon. We talk about the future, we start talking about the ancient past. We did a trip to one of the objects which is the oldest in the solar system, a comet, and the story of this trip I'm going to tell you today. This is the way mankind saw comets throughout its history until just a few hundred years ago. A mysterious stripe in the sky, it appears, stays there for a couple of weeks, maybe a month. Nobody knew what they were. They were interpreted as signs from the gods of good luck, of bad luck, and signs for the future. In fact, they may have brought bad luck. If we know that comets have hit the Earth, we know that comets have influenced life on Earth, they influenced the history of Earth, and they left scars like these craters. They will hit again. There's so many comets around the universe and the solar system, and they will come back. So it's very important to look at comets also for the future of our planet. It was only until a few hundred years ago, when telescopes were invented, that we could see a bit more what a comet is. But even with the most powerful telescope, you see here a picture of Hale-Bopp, a very nice comet that came about 20 years ago. Even with the most powerful telescope, you can only see this very long tail of gas, of dust. What is the origin of the comet, which we know today is a little piece of rock, like a mountain, which in a universal scale is really very small, is not visible from Earth. In order to see it, you have to have a satellite. But at least with telescopes, we could determine the orbit of the comets and the theory of where they come from. And we know they come from two reservoirs very far away from the sun, the periphery of the solar system, the Kuiper belt and the Oort cloud. We know that they are the remnants of the initial phase of the solar system. They are the oldest objects that we can think of in the solar system, and preserved because they stay so far away from the sun. They are frozen, they are very cold. When they fall towards the sun, then they heat up and they start emit gas and dust. The first time we saw how a nucleus of a comet looks like was only 30 years ago. This is a film which was made by a European spacecraft called Giotto, and you see it filmed this comet, the nucleus of Comet Halley, about 15 kilometers big, and it flew by very fast at a velocity of 60 kilometers per second. We didn't know how it looked like, but now we had an idea. We didn't only take pictures, we had, of course, measurements. So we started modeling these nuclei. There were more missions. In fact, in total, there were 5 missions in history that visited the comet. But all these missions were what is called a flyby. So it was just shooting such that the spacecraft would fly very close to the comet, say a few thousands of kilometers, but it would stay in the vicinity only for a few hours. We wanted to do more, and that's what we did with Rosetta. When we started about 20 years ago, that was our mission. We wanted to rendezvous with a comet, which means reaching a comet, but staying there for a long time, not a few hours. In fact, we plan to stay there 2 years, and that's what we are today. And since we were rendezvousing with the comet, we decided to bring a lander with us. So we dropped also a little lander to the surface. This was unthinkable a few decades ago, but 20 years ago, that was the task we were given. We had to travel 10 years, we had to travel 7 billion kilometers, and we reached distances from the sun which no spacecraft with solar panels had ever reached before. So it was a big challenge. That's the trip we did. If you follow the white line on the screen, that's the trajectory of Rosetta. In order to reach the comet, you have to go as fast as the comet, and they're pretty fast. There's no rocket that brings you to that speed. So we had to use a trick. We did various tours of the solar system, and we came back several times to a planet, through the gravity of the planet, 3 times Earth, once the Mars, we could accelerate the spacecraft. And in that case, you see here, for example, a flyby of the Earth the second one, and you see every time the orbit gets larger, it means that we are faster, we have more energy, and we can reach the comet. It took 10 years because of that, but we had another challenge to face. When we finally had enough velocity, like you see here, to follow the comet, we reached these enormous distances from the sun, and we had to switch off the spacecraft. We had not enough power on our solar cells to keep the spacecraft active. So this was a big challenge. We switched it off for 2.5 years. We set a timer on it to wake up exactly 2.5 years later, on the 20th of January 2014. It was not a nice period. Imagine we have this spacecraft flying for 2.5 years in the cold space out there, and we had no news from it, no signals for so many months. So the day of the wake-up was the 20th of January 2014. We had a window of one hour between 6:30 in the evening and 7:30 in the evening, where we had predicted that the signal from Rosetta would come back and the spacecraft would say, hello, I'm back, I'm awake. We started, I'm sitting there next to the flight director in the control room, and we were quite relaxed in the beginning. This was 6:30. Around 7 o'clock, there was no signal. We started to be a bit nervous, but the signal kept us waiting. This is what we looked like at 7:15. We were very, very nervous. There was no reason for the signal to be so late. We knew we had a window of an hour, but we were really confident it would come a bit earlier. Eventually, the spacecraft decided to let us wait 49 minutes, but eventually this signal came. You see the spike in the radio signal, and this spike told us Rosetta was awake, Rosetta was alive, and it was working. So, of course, this was the reaction in the control room. This was a very important moment of this long trip, but it was just the start of the difficult phase. Then we had to wait 2 more months to get slowly closer to the comet. That's the first picture we took from Rosetta of our target comet, from 5 million kilometers distance, and you can recognize in the middle, in that red circle, the comet, our target. In July 2014, we first could resolve the nucleus, and this was a big surprise from the scientists. Again, remember, from Earth, you cannot see this thing. We were flying into the unknown, and we saw this very strange shape. Somebody called it a rubber duck, somebody called it a scamorza. Anyway, a very strange shape, very, very difficult to predict. Rotating not that fast. It's actually rotating with a period of 12 hours. But this made us a bit concerned because we wanted to land on this thing. Slowly we came close, and this was the new challenge for us. Nobody had ever come so close to a comet. Nobody has ever flown in the vicinity of the comet with all this dust and all this gas around. Fortunately, in that period, the nucleus was not so active. We were still far away from the sun. But the navigation around it was a completely new challenge. We were doing it for the first time. And we were doing it while we were flying. What we had to do was to design trajectories that could characterize the comet. We had no idea of the mass of the comet. And in order to orbit this object, you need to know the mass. So we used, with these very strange trajectories at a distance of 100 kilometers, we used the spacecraft as a sensor of gravity. And by measuring the bending of these trajectories, eventually we knew the mass of the comet. We know that it's a very light object. It weighs less than water in terms of density. It's about 10 billion tons, still quite big. After we measured the mass, we could go into orbit very gradually. But the job was not finished. We had to learn of the dynamics of the environment. So we had to learn what the gas looked like, what the dust looked like, all these forces that were affecting our navigation. So we did all these very complex set of trajectories, also to take pictures of the comet and develop a digital model of it. It took about 2 months until we finally, in the beginning of October 2014, we were able to go down to a orbit of 10 kilometers. The comet itself is about 4 kilometers big. So this was flying very, very close to it. And that was the end of the characterization phase. Now we knew how to fly around it, and now the next challenge for us was the landing. We had to navigate even more accurately for the landing. We had to determine very precisely where we were compared to the surface of the comet. So we invented a completely new way of navigating, which we called optical navigation. If you want, it's a very similar system compared to what you have in your smartphones, where you use radio signals from satellites to know where you are. Here we couldn't use radio because the comet was not sending us signals. We used pictures. We took various pictures of the surface, we identified landmarks, and then we could determine where we were flying related to the comet. Again, another big challenge that we had in front of us. Finally, the selection of the landing site. You see the surface of this object is extremely rough. There's no nice landing place for an object, and we had to do it fast because we wanted to land in November so that the comet was still far away from the sun and not too active. We selected landing site J, and then we did the landing. The landing was pushing away gently our landing module, which was called Philae. And from an altitude of 22 kilometers, it took 7 hours. It just fell. It was just throwing a stone. And it worked pretty well. These are pictures that are taken from the lander itself. We hit the landing place pretty precisely, within 120 meters from the center of the target. So we were very happy with that. Our job, at least the job of Rosetta, was done. However, the lander decided to play a trick to us. You have to imagine that on such a small object, there's no gravity, or very little gravity. So the lander doesn't just fall to the ground and stay there. So we had a system to anchor it to the ground, to firing 2 harpoons into the ground. Well, this firing didn't work. And you see in this picture here, in the blue circle, you see the footprint of the lander where we landed, but then you see on the red circle, the poor Philae was jumping around. And it did bounce around for 2 hours on the surface until, fortunately, eventually it stopped. It stopped into a very dark hole, very interesting for the scientists, but unfortunately extremely dark. So the lander could survive with its prime batteries, did 3 days of experiments, which was the primary sequence, but it could not survive longer. It was too cold and too dark. We had to wait and see whether with the new season on the comet, maybe more sun would wake it up. In the circle you see there, in the top left, you see the landing site, and in the ellipse there, where we think it is ended up. In the meantime, while Philae was sitting on the comet and waiting for us to perhaps pick up another signal in a new season, Rosetta went up, continuing its observations around the comet. But the activity of the comet increased. You see, all the gas that is blown away, there are explosions on the surface. It's like a geyser. So we had to fly further away from the surface. But we kept doing science. We kept doing these marvelous pictures. Here you see a landscape on the surface of the comet, or here you see a wonderful peak, which is about 100 meters high. It makes you think of base jumping. Here, without parachute, you could jump from this and not hurt yourself. In fact, the gravity is so small that it would take you 20 minutes to do the 100 meters. So not very exciting, indeed. Never mind, it's nice. We look under the surface of the comet because with these gas explosions, the comet shows us the interior, like in these holes. We see wind on the surface. This is amazing in a place which has no atmosphere. But all these studies are being done at the moment by Rosetta, which is still around the comet, and it's detecting and learning all these interesting things about this mysterious object. There's still more work to do. At the moment, the activity of the comet is going down. We're getting closer again to the surface. We plan by the end of the year to go back to the circular orbits that you saw before. But we have to finish the mission in September next year, because by then we will be so far away from the sun, together with the comet, that we will not be able to operate our spacecraft anymore. So we've thought of a glorious end. We will land with the mothership, with Rosetta, we will land on the surface of the comet. This was not planned originally, but we thought it's a nice way to finish this incredible mission. By the way, I indicated here the various websites where you can still follow this mission, and it's very exciting. Every day, every week, we have new images and new interesting discoveries. But I want to finish my talk talking about the future. One of the important byproduct of this mission, lasting 20 years, covering almost 3 generations of scientists and engineers, is the team that we built up. I took a few pictures of my team here. These people were hired 15, 20 years ago. They were very young. They grew into this mission. Now they represent an incredible reservoir of expertise, which is the future of space exploration. These people are the future. They will make the next step. They will go further in the solar system. They will design and operate the new missions. I think this is one of the main results of Rosetta. It will do scientific discoveries. It will do technological advances. But it has created a new generation of space explorers. And I think, as I said, this is the main message for the future. These people are the core. Finally, just to show you, I started saying we went to a very ancient place, and we did it because we want to know the history, but project the history into the future. Even in our 20 years trip, we started with a spacecraft design in '96, where internet was still in its childhood. We launched 5 years before the smartphones were invented. Nevertheless, we managed to teach our spacecraft last year to take a selfie, and that's what it did. Yeah? So this concludes my speech. Remember the selfie or Rosetta and think about the future. That's where we're going to be. Thank you.